Hello all, welcome to NPTEL GATE Live Interaction Session 1. Myself, Kanneganti Bhargav, I'm a PhD scholar in Water Resource Department in Institute of Science, Bangalore. So today we are going to see this particular topic called estimation of missing data. Suppose when we have the long series of the record, such as like a precipitation data or stream flow data. Suppose if any year one value is missing, when suppose if the instrument is not operative, then how we can estimate that particular value by using the neighborhood information from the neighborhood stations. So let's start with this. So imagine there is a catchment which has m plus 1 stations, and these m plus stations have like a m plus stations, and let p1, p2, p3, and so on PMR given annual data at m neighboring stations. And suppose this p of x station, if this p of x station is not operative at any given time, so how we can estimate this px by using this neighborhood information from the neighborhood stations, that we can see. So there are two procedures to do. So before that, so we can calculate the normal annual precipitation at each station. So how we can calculate the normal annual precipitation? Let's say, suppose like we have the data as follows here in the data. Suppose 1971, 1972, and so on 2001, let's say, and each year has we have a some value p1, p2, and so on pn. So the normal annual precedence shall be calculated as the of this value, average of this sum. So it can be calculated as, suppose we can denote it with a capital letter M, and the denominator, like the suffix could be the station name. Let's say for example X. So it can be calculated as, for example, 1 by 30 divided by equal to 1 to n. This 30 can be n pi. So in this way we can calculate that. So the minimum length of n should be 30 years. 30 years. So similarly, the same normal annual precipitation we can calculate for all the other stations as well. Suppose first, suppose like let's say our interest is to estimate the px value by using the neighborhood stations, by using the information from the neighborhood stations. So we know normal annual precipitation for all the stations, like let's say N1, N2, N3, and so on, Nm. Suppose if all these normal annual precipitations are within the range of nx minus 10% of nx, comma nx plus 10% of nx. If all these normal values of neighborhood stations fall in this range, then simple arithmetic method is sufficient. That is p of x equal to 1 by m p1 p2 and so on pm. If this condition is not satisfied, means that any one station has a normal annual rainfall which is beyond this range, then we can use normal ratio method. In this ratio we will use the weighted average. So it can be calculated as Ex equal to Nx divided by Nm P1 divided by N1 plus P2 divided by N2 and so on PM divided by Nm. So in this way we can calculate the Px by using the normal ratio method. So now let's see the problem what we want to see. So to understand to give more picture on the topic, let's solve one question. So this question is taken from gate 2015 session 1. The question number is 57. So here in a catchment there are four rain gauge stations P, Q, R and S. The normal annual precipitation values at these stations are 780 mm, 850 mm, 920 mm and 980 mm respectively. In the year 2013, stations Q, R and S were operative, but P was not. So using this normal ratio method, so here it is already mentioned that using the normal ratio method, so no need to check that range. The precipitation at a station P for the year of 2013 has been estimated as 860 mm. If the observed precipitation at the stations Q and R for the year 2013 were 930 mm and 1010 mm respectively. So the question is, what was the observed precipitation in mm at a station S for that year? So here this already the rainfall missing precipitation value is estimated and this has given here. So but it has been asked to estimate the observed precipitation at a station for that year. So let's see how we can solve this question. So let's get the data. So gate 2015 session 1 question number 57. So what are given data? Let's set a given data. So pp, pq, pr, ps means that precipitation in year of 2013. So what are they? So for year 2013, 860 mm. This one is the estimated one. PQ 930 mm, PR 1010 mm, and PS. This has to be estimated. And what are other information he has given? NP. What is NP? NP is 780 mm. NQ is 850 mm. NR 920 mm. NS 980 mm. So this is the information given. So now it is already mentioned in the question that using normal ratio method. So it is already mentioned that. So we'll rightly write this formula. So by using normal ratio method, this particular value is estimated. So write this formula in terms of that. NP divided by here what is M? M will be 3 because we are looking at M plus 1 stations now. So here it will be PQ divided by NQ, PR divided by NR plus PS divided by NS. So let's substitute the values. So values will be 860 equal to NP will be 780 divided by 3. So PQ is 930, NQ is 850, PR is 1010, and NR is 920. PS is to be estimated, NS is 980 mm. So note down, note all values are in mm only. Note all values are in mm. So reshuffle the terms. So by solving this thing, we will get 1063.2 mm. So I hope you have understood this question.